Let me start with a simple question. Imagine you've just synthesized a carbon-13 or deuterium labeled compound. On paper, everything looks perfect, but how do you actually confirm that the labeling is truly complete? How do you know if your compound is 99% labeled or only 90%? This is where isotopic purity becomes critical. In this presentation, I'll walk you step by step through how LC-MS helps determine isotopic purity accurately, reliably, and practically, using the same workflow followed in pharmaceutical and research laboratories worldwide. First, let's understand what isotopic purity really means. Isotopic purity refers to the percentage of molecules that contain the desired heavy isotope, such as carbon-13 or deuterium. But in reality, your sample is rarely perfectly uniform. Some molecules remain completely unlabeled. These appear as M+0. Some are partially labeled. These appear as M+1 or M+2. And finally, the molecules that contain the full intended labeling appear as M+N, which is your target species. Our goal is to measure how much of your sample actually belongs to this target labeled category. Now you might wonder, why do we use LC-MS for this analysis? The answer lies in its incredible sensitivity and precision. LC-MS can detect even trace isotopic impurities, down to levels as low as 0.1%. It also offers extremely high mass accuracy, allowing it to resolve differences as small as a single neutron. Most importantly, LC-MS allows accurate quantification by measuring peak areas for each isotopic variant. This makes it the gold standard tool for isotopic purity determination. Everything begins with proper sample preparation. Your sample concentration must be carefully controlled. Typically, dissolving the sample at 1 to 10 parts per million ensures accurate detection without saturating the detector. Always use LC-MS grade solvents like methanol or acetonitrile. Even small impurities in solvents can produce unwanted peaks and affect your results. And finally, filtration is essential. Filtering through a 0.22 micron membrane protects your LC column and ensures clean, reliable data. Good preparation ensures good results. Once the sample is ready, we move to data acquisition. Here, we optimize the LC-MS settings to capture the full isotopic profile. Electrospray ionization is typically used because it is a soft ionization technique that preserves molecular ions. We run the instrument in full scan mode so that all mass-to-charge variants can be detected. We also carefully record retention time and mass spectra. This information forms the foundation of isotopic purity analysis. Now comes one of the most important steps, identifying isotopic peaks. When you examine the mass spectrum, you'll see peaks separated by one mass unit. For example, a peak at mass 500 represents the unlabeled species. A peak at 501 represents partially labeled molecules. And the peak at 502 represents the fully labeled target compound. These peaks reveal the true isotopic composition of your sample. Next, we extract peak areas for each isotopic species. This is done using extracted ion chromatograms, or XICs. It's important to use peak area instead of peak height, because peak area accurately reflects the actual concentration. We must also ensure proper integration by applying consistent baselines and excluding noise or impurities. This ensures precise quantitative results. Now we calculate isotopic purity using a simple formula. We divide the target peak area by the sum of all isotope peak areas and multiply by 100. For example, if the target peak area is 990 and the total area is 1000, the isotopic purity is 99%. This number tells us exactly how efficient our isotope labeling was. Before concluding, let me share some important practical tips. Always avoid detector saturation, because it can distort quantitative accuracy. Using high-resolution mass spectrometry improves peak separation and accuracy. And always repeat your measurements, ideally 3 times, to ensure reliable and reproducible results. These practices ensure confidence in your data. To conclude, LC-MS is truly the gold standard technique for determining isotopic purity. Accurate isotopic purity determination is essential for pharmaceutical research, tracer studies, and analytical applications. The key steps are simple but powerful. Careful sample preparation, precise data acquisition, and accurate calculation. When performed correctly, LC-MS provides reliable and highly accurate isotopic purity measurements. And ultimately, this ensures the integrity and success of your research.